In this video we want to talk about discounting methods for investment appraisal, and in particular we want to look at the net present value and internal rate of return calculations. There are two methods for investment appraisal, and these are the net present value method and the internal rate of return. It's not 100% accurate to say that there are only two methods. There are other methods that may be used, for example the payback method and so on, but these are two of the more technical areas and the ones which crop up most in our consideration of investment appraisal techniques. So these are the two big methods, if you like, the ones that we tend to focus in on mostly. Now these methods take into account the total returns from a project and also the timing of those returns. Now that's important because it looks at all of the returns right across the life of the investment, and it looks at when the returns are made as well. For example, if it's an investment in a machine, does the machine yield a return every month or every year, or perhaps every 10 years? And that will make a significant difference to the way in which we see that investment. The returns on an investment that are received early are preferable to the returns received later. This is known as a positive time preference. By and large, all of us tend to prefer something now than something in the future. We prefer to have it straight away if possible. So given a choice between, let's say, a present of £100 now or £100 in a year's time, by and large we prefer to have it now. Now, this is known as our time preference, our positive time preference. In order for us to choose the £100 in a year's time, we would need some compensation, perhaps something more than £100, to make us decide to wait for the extra period of time. So let's look at the techniques. So returns received earlier have the following advantages. So returns that we get earlier have the following advantages. The money may be reinvested at a rate of interest. So if we get our returns early, then we could reinvest that sum of money and get even more returns into the future. So it's advantageous to get our returns early. The money may be invested in a new capital project, not just put into the bank, so we could look around to see what investments are available and what we should do with the early returns that we've received, and perhaps even invest in another project. They can also be used to ease cash flow problems. Sometimes companies have a cash flow problem. Perhaps there are times during the year in which sales are low and the company still has to pay wages and salaries and overheads and so on, so it may have a cash flow problem. So receiving a return on its investments early can help it overcome those problems. So that could be an advantage of early returns. They also reduce the risk of the investment. Getting the returns early means there is less risk in the investment. There is less that can go wrong. So it reduces risk. And returns stretching out into the future may be affected by inflation. So getting £100 now or £100 in a year's time, well, in a year's time inflation may have been, say, 5%, so in fact we're only getting 95% in a year's time. So it's important to get the returns early if possible. And back to this idea of positive time preference. Well, in general we prefer returns now rather than having to wait. early returns have greater weight as compared to the returns in the later years. By and large, we prefer to receive our returns as soon as possible. We don't like to have to wait. We have what's known as a positive time preference. And it's also backed up by what we've just said earlier in terms of having the facility or the ability to reinvest the returns, to undertake a new project perhaps, to ease cash flow, as I said, and also reduces the risk of the investment. And in addition to that, of course, there's less worry about inflation eroding the value of the returns into the future. So by and large, we prefer to have the returns as soon as possible. There are two ways of calculating the net present value of an asset. We can do it by formula, and we can also do it by tables. There are special tables that accountants and finance experts have prepared over the years. So there are two ways in which we can calculate the net present value of an asset. If we invest in a project and the project exists in a year's time, we need to know how much is the project valued at in a year's time. And the only way we can do that is by discounting it back to the present and comparing it with some alternative. Let's see how it works. Let's talk about the formula first. Imagine you put £100 into the bank at 10%. So the rate of interest in the bank we'll assume is 10%, and imagine you just put in £100. At the end of the year, you'll have £110. You'll get the original £100 you put in plus the interest, which is £10. Assume that your rate of time preference is 10%. So you need 10% to make you indifferent between receiving the money now or receiving it in a year. So you're indifferent between £100 now and £110 in a year. So that means your rate of time preference is 10%. That's what makes you indifferent. In other words, £100 now is the same as £110 in 1 year's time. Now, let the present value be P, that's the present value, and the amount you receive after a year as A, that's the amount, A, and the rate of interest, we'll call it R. So, the amount you get is the present value, P, times 1 plus R. In other words, if we substitute in to make sure that that formula is correct, we put £100 in, 100, so P is 100, into, or multiplied by 1 plus 10%. 10% is just 0.1. So we have 100 multiplied by 1 plus 1. 0.1. Sorry. In other words, 100 times 1.1, which is just 110. So the formula works. So we have A is equal to P into 1 plus R. That's our formula. That's our previous calculation, the one we've just done. I just moved it on to this sheet, to this slide, so that we can see it and work with it. So we know that A is equal to P multiplied by 1 plus R. Now if you left the £110 in the bank for another year at 10%, it would grow as follows. Now you leave in the 110 for 2 years, in other words. You put in 100 and you leave it there for 2 years at a rate of interest of 10%. So now what we get is, at the end of the second year, it's P is equal to 110, because that's what the bank has got at the end of the first year, multiplied by 1 plus 0.1. In other words, 110 multiplied by 1.1, which is 121. So at the end of 2 years, our initial sum of £100 has grown into £121. So in other words, £100 left in the bank for 2 years, earning 10%, will grow into £121. Start with £100 and put it in the bank for 1 year at 10%. So we have A is equal to 100 times 1 plus 0.1, which is 110. Now, leave this £110 in the bank for a further year at 10%, and it'll grow into £121. There's the formula. That's how we calculate it. We would write this as follows. A is equal to the £100, which has grown into, at the end of the year, into £110, and it grows into 110 because it earns 10% rate of interest. So it's 100 multiplied by 1 plus 0.1. So it's 110 at the end of the year. However, we leave it in the bank, so it goes on to earn another 10%. So we get it to 121. In other words, the 1 plus 0.1 happens twice. And when you multiply any number by itself, you really square the number. So our formula now has become A is equal to 100 times 1 plus 0.1 squared. 2 years, so it's squared. And this is the start of our formula. Now you can see where we've got to so far. If you left your money in the bank for n years, the rate of interest remained at R is the rate of interest, your money would become A is equal to 100 times 1 plus R to the power of n. If you like, A is equal to P multiplied by 1 plus R to the power of n. And how we get that formula is by just looking at the logic of what we had above. Just put the cursor onto the screen for a moment. If you look at this formula here, the logic of this, how we got this, is by looking at what's happening up here. Here we have 2 years, and you can see it's the present value, 100, times 1 plus 0.1 squared. That's 2 years. The 0.1 is the rate of interest. Now, just write it out again, and that's what we get for n years. This means that the present value of a sum of money to be received in the future is given by the formula P is equal to A divided by 1 plus R to the power of n. And where P is the present value of the net return, A is the sum received in the future, R is the rate of interest, n is the number of years. So it's based on this calculation. Put the cursor back on. It's based on this calculation up here. And we've got this formula here from this one. If you divide the right hand side over here, if you divide that by 1 plus R to the power of n, we just get P on its own. But if you divide the right hand side by 1 plus R to the power of n, you must do the same to the left hand side. So divide the A by 1 plus R to the power of n. And that's our formula here. That's exactly where we got it. Example. What is the present value of £100 to be received in 2 years' time if the rate of interest is 10%? Well, we'll use our formula. So, here's our formula, and we've inserted the figures in. There's the present value of £100, so that's the amount we get at the end of 2 years. And the rate of interest is the same for the 2 years, we're assuming, at 10%. So it's 1 plus 10% squared. Now, if we evaluate that, we have 100 divided by 1.1 squared, which is just 100 divided by 1.21, which is £82.64. So if I was promised £100 in 2 years' time, and the rate of interest currently is 10%, that's the same as £82.64 today. It's exactly the same if my time preference is 10%. What is the present value of £100 received in 2 years' time if the rate of interest is 5%, together with a sum of £200 received in 3 years' time? A bit more complicated. So what's the present value of £100 received in 2 years' time if the rate of interest is 5%, together with a sum of £200 received in 3 years' time? Well, that's it. That's the calculation. I receive £100 in 2 years' time, so I discount that at 5%. There it is. I'm also going to get £200 in 3 years' time, so I discount that at 5% as well. There it is. So I need to calculate this, and I know what it's worth today. So just square the first one and cube the second one. 1 plus 0.05 cubed, and you'll see the figure on the denominator of the second expression. Add the two together when you divide out, and you find it's £263.47. So £100 in 2 years plus £200 in 3 years, if the rate of interest is 5%, is the same as £263.47 right now. We could do this with discounting tables. I said earlier there are two ways of doing it. To avoid having to check the figures every time with the formula, accountants and finance experts have come up and compiled discount tables to help with the task. This is just taken out of some table, and I've just typed it out here. So, for example, we have years on the left hand side from 1 to 10, and then we have representative rates of interest: 2, 4%, 6%, 8%. We could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on percent. They exist, but for this calculation we just took some representative ones: 2, 4, 6, 8, and so on. And inside each of these there are figures like this one here, 0.9804, 0.9612, and so on. Now let's use an example here. Let's say we want £100 in 4 years' time. Assume the interest rate is fixed at 6%. Now look at the table. Let's go back to the table for a moment and see if we can track down. We're going to go for £100 in 4 years' time, 6%. 6% is over here, and 4. So the relevant number seems to be 0.7921. Please remember that. 0.7921. Make a note of it. 0.7921. Okay, now let's go back to where we were. Now we find 4 years and read across until we get to the 6, and we get 0.7921, like I said earlier. So there's our table, and 4 years, 0.79, what was it again? Have I picked up the wrong figure? I've actually picked up the wrong figure on here, would you believe? It's this one here, 6%, isn't it? It's 6% over 4 years. So that slide is actually wrong. This is the correct one here. So let's say we want £100 in 4 years' time. That's where I got confused. Assume that the rate of interest is 6%. Now look at the table. Now find 4 years here and read across until we get to 6. Take 4 years and read across until we get to 6%. There it is, 0.7921. And multiply that by 100, so we get £79.21. So this figure here just saves us doing the mathematics, if you like, saves us doing the calculation. And these tables exist. In fact, it's possible to look them up online. Or nowadays, most reasonable calculators can do this calculation very simply. It means the £79.21 means that that we put £79.21 in the bank for 4 years at 6%, we'd get back £100. That's just reversing it, and that's what it means. Suppose that a company is considering the purchase of a piece of capital equipment costing £120,000. And let's say the company wants 8% discount rate. If the equipment yields a return of £35,500 over a 5-year period and has a scrap value of £7,000 in 5 years, is it worth buying the equipment? So it gives a return of £35,000 over 5 years, 35,500 every year, and at the end of this period, the end of 5 years, it has a scrap value of £7,000, and we want to find out if it's worth buying this particular piece of machinery. Now the calculation would be as follows. Well, we would set up a table. I'll just put the cursor on. We set up the table here. This is right now. 0 is right now, and we spend 120,000. So that's going out. It's minus 120,000. And with absolute certainty about the 120,000 because we have it in our hands right now. So the discount rate, if you like, is 1. It's what we've got right now. So its present value of this 120,000 is 120,000 because we've actually got it right now with us. Now if we buy the machine, it's now invested in the machine. Now we get 35,500 every year for 5 years. But the value of the 35,500 we get every year is diminishing. We can look this up in the tables we had earlier, and you'll see it is diminishing. Or we can use the formula we had earlier as well if you wish. And this means when you multiply 35,500 by 0.9259, we get 32.87. Next one will be 30.34, 28.18, and so on. So you can see what we're getting back over time is diminishing. And then we're getting a scrap value of 7 at the end of this period, which multiplied by, in 7 years' time, the discount factor is 0.6806. Multiply 7 by that and we get 4.76. Now add it all up, and you see that the figure here is positive. If you add it all up, allowing for the minus 120 at the start, minus 120 plus 32.87 plus 30.34 plus 28.18 and so on, all the way, you'll find it comes to 26.4. This figure is positive. It's a positive figure, and therefore it's profitable to purchase this piece of capital equipment. So that's how we use discounting in terms of investment appraisal, to try and find out if it's worth investing in a particular project. Clearly there are issues associated with this that need to be stated. For example, here in this example we have the value of the machine right now is 120,000. That's what we're paying for the machine right now. We know that with certainty. And the return at the end of the next year is 35,500. And there's the problem. How do we know it's 35,500? A lot of things, many things can happen over the year. Many things can happen over 2 years or over 5 years. How do we know the return at the end of 5 years will be 35,500? How do we know we can sell the machine for scrap at the end of the 5-year period for 7,000? So this technique does not cope very well with uncertainty and risk. If we could see the future very clearly and we were certain about the future, this technique is excellent. Unfortunately, we can't see the future, and this makes this sort of calculation, it's the best we've got, the best we can do, but it's still down to entrepreneurship to make capital investment decisions. It is the entrepreneurs who have to decide and take the risk and try and work out if it's a good investment or not. This precision that we get from these type of techniques is interesting, and we should be able to do these calculations, but we have to bear in mind that we don't know what the future holds, and we're not sure of the figures that we're putting in here. So, having said that, that completes our talk on net present value, internal rate of returns, and positive time preference, and investment appraisal. There will be more videos on this topic, so watch out for those. But in the meantime, let's leave it at that and say thank you for watching.